Okay, in this video we're going to go through this problem here. The problem is a ball is thrown vertically upward from the top of a cliff. The height of the ball above the base of the cliff is approximately modeled by h equals 210 minus 5t minus 5t squared, where h is the height in meters and t is the time in seconds. So what this is saying before we dive into the questions is that essentially I have this relationship, and I'm going to rewrite it here, where my squared term is the leading coefficient. So what it's saying essentially is that this is a relationship where if I put in any t value, so t is the independent variable, the independent is t, put in any t, I get an h, so the dependent is h. So what's happening essentially is that there's this guy or girl standing on a cliff. Here he is. And he takes this ball and he throws it. And notice the ball is thrown vertically upwards from the top of a cliff. So it's not thrown out like this. That gets a little more complicated. All we do is imagine reaching your hand over the cliff and throwing it straight up. So that ball is going to go up. Eventually it's going to curve around. It's going to come back down. Eventually it's going to hit the bottom. So the bottom of the cliff is h equals 0. This is the starting point, right? And whenever we start this, t is equal to 0. So that's kind of what this relationship is modeling. So when we want to know how high is the cliff, well, we know that the ball starts at the cliff edge. So at t equals 0, ball is thrown from cliff. So therefore, we're going to evaluate h when t is 0, so that's equal to negative 5 times 0 squared minus 5 times 0 plus 210. So therefore, h is equal to 210 meters. Now, a nice observation to make is that whenever you plug in 0 into this relationship, it's going to be your c term, the constant that ends up being remaining. Now, a little side note for those of you in my class, we talked about function notation. So this would be a case where I could actually write some function notation just to kind of help communicate what I'm doing. I could write this instead of h as a function of t. So what this helps me with is it simply helps me articulate what I'm doing. So if I want to evaluate this function, remember a function is just a special type of relationship, the definition of which we'll explore a little later, is I can actually communicate this nicely. I can say h at 0. So this means what is the height when the time is 0. And remember, whatever I place t within there, I replace in the equation. And that's equal to 0, and I'm done. Okay? So how long does it take for the ball to reach a height of 150 meters from the base of the cliff? So how long does it take the ball to reach a height of 150 meters from the base of the cliff? So the base of the cliff is the very bottom of the cliff. So therefore, we're interested when h is equal to 150. So all I do here is to say 150 is equal to negative 5 t squared minus 5t plus 210. And again, I see right here I have a quadratic, so in order to solve this, what I want to do is get 0 on one side. So 0 is equal to minus 5t squared minus 5t. And then we're going to have 210. I'll write the step here, though often we'll just do this. Minus 150. So 0 is equal to minus 5t squared minus 5t. So 50, that's going to be plus 60, I believe. There we go. So now, right away, now I see, oh, perfect. I have this quadratic, this trinomial. I can factor it. But remember, we always want to, and I want to really stress this, attempt to common factor. Common factoring will make your work easier and speed you up. So here I see a common factor for each of the terms is -5. I could factor out 5, but I like to make the squared term positive. So we're going to get t squared plus t minus 12, I believe. I've done this correctly. And then some students will make the observation, say, hey, I have 0 on this side. So let's divide both sides by 5. So I get 0 is equal to t squared plus t minus 12. Now let's come up here. So what I need is I need two numbers whose product is -12 and whose sum is 1. So we know these products are going to differ by 1, or sorry, these two numbers are going to differ by 1. And the positive number, well, if the product's negative and the sum's positive, that means that one of these values is going to be positive and negative, and therefore the larger number is going to be positive, right? So therefore, my two numbers, I can do this, are going to be +4 and -3. So therefore, I can factor this very quickly to t plus 4 and t minus 3. So therefore, t is equal to -4, t is equal to 3. Now, what should really jump out at me here is, well, why is this t equals -4? That doesn't make sense because time can't be negative. So since time can't be negative, I'm going to discount that answer. And let's rationalize why that makes sense. If you take a look at this, notice we start at 210 meters on the cliff. So 150 meters is somewhere along here. So that means that I'm going to throw this ball up in the air. It's going to go up higher above 210, and then it's only going to hit 150 on its way back down. So that means that it's going to hit 150 on the way back down. So really, the takeaway from this is watch for negatives. So watch for time is less than 0. If time is less than 0, it means something in context to the problem. Okay, let's look at the last part. How many seconds does the ball hit? I should say, does it take for the ball to hit the ground? Oh. So when the ball hits the ground, again, all these questions are pretty much figuring out what is h or what is t. So when the ball hits the ground, height is equal to 0. So therefore, we can just simply say 0 is equal to -5t squared minus 5t plus 210. And then what I'm going to do here is I'm going to factor this. And in fact, I'm just going to divide both sides by -5. So I get t squared plus t, and then 210 is going to be minus 42, I believe. So now I'm going to go through and factor this. When I factor it, again, if we look at my little diagram here, the ball hits h of 0 here. So if I imagine the ball, I know the ball starts right here and gets thrown up, but imagine if we just bring the ball back all the way down like this. That means that one time should be negative and one time should be positive. And so if we go and factor this, let's just scroll down a little bit here. 0 equals, we need two numbers that multiply to give me -42, but they add to give me 1, and those two numbers are going to be 7 and -6. So I'm going to say t plus 7, t minus 6. So therefore, t is equal to -7 or t is equal to 6. And again, -7 is back in time. So since it's back in time, we're going to discount that answer. And we're done. I hope this example helped.